Hi everyone, welcome to Neetshala Organic Chemistry Revision Lecture Series Part 3. In this part, we will be covering the topic of benzene and we will be also completing the chapter hydrocarbons. So let's get started with the topic of benzene. The first part is the structure of benzene. Now everyone knows that benzene can exist in two resonance forms, and these two forms are known as the Kekulé structures of benzene. So since the pi electrons of the benzene are always rotating from one position to other position, so we can represent it in the form of a circle. So this will say that the electrons are moving in the form of a circle from one position to the next position and from there to the next position and so on, so as to become stable. Now, what is the impact of this particular delocalization of the pi electrons on the bond length of benzene? So let us see it one by one. X-ray diffraction data reveals that benzene is a planar molecule. It is not a non-planar molecule, it is a planar molecule. Now, if we have any one of these structures correct, then what happens? We have the correct bond length of C single bond C and C double bond C. But since we do not have a particular structure as the exact structure of benzene, so we observe that the carbon-carbon bond length in benzene is intermediate of that which is expected from the normal carbon single bond and carbon double bond carbon bond. If I take the carbon single bond carbon bond in other molecules, it is 154 picometer and carbon carbon double bond is coming out to be 133 picometer. But the bond length of carbon carbon bond in benzene molecule is intermediate between these two, that is 139 picometer. So this is the most important observation which we can expect or we can conclude from this particular Kekulé structures. Now, the absence of pure double bond also has another impact, that is, benzene shows a slight reluctance to show addition reactions under normal conditions because it has somewhat a single bond character and also somewhat a double bond character, right? And due to the presence of this, it shows a slight reluctance towards addition reactions. Now let's start with the preparation of benzene. We have three methods of preparation of benzene as mentioned in NCERT. So let us look at the first method, that is the natural or the commercial method of preparation, that is from coal tar. Second is by the cyclic polymerization of ethine. These are the chemical methods. We have one more coming up. So first let's discuss these two. The cyclic polymerization of ethine, which we have already discussed in the previous lecture, where we have an ethine molecule. We will take three such molecules and this is treated with red hot iron. This is treated with red hot iron or copper at 873 Kelvin to convert into benzene. And we have also discussed a question based on this in the previous lecture. Now let us see the decarboxylation of aromatic acid. We have already studied how the process of decarboxylation is carried out in normal acids, right? In the straight chain acids. But now we have the aromatic acid over here. So again the same thing, we have to treat it with soda lime. Soda lime, as you remember, is a mixture of NaOH and CaO. So we are going to remove the Na2CO3 part, that is NaO from NaOH and NaOO from the other part, so that Na2CO3, the complete part, is going to move out and this hydrogen which is left, that is going to be substituted onto the benzene ring and we get the benzene here. This is the second method of preparation, that is decarboxylation of aromatic acids, which follows again the free radical mechanism. Now the third one is the reduction of phenol, and this reaction is important. It has been asked in NEET and also in many other competitive exams as well, and it is quite easy. If we are adding zinc dust, if we are adding zinc dust to phenol molecule, we will be getting benzene along with zinc oxide. So this is the third method of preparation of phenol, and this completes the methods of preparation of benzene. Now let us see the next topic. which is the properties of benzene. First, let's discuss about the physical properties of benzene. Benzene or any other aromatic hydrocarbons are always non-polar molecules, and they usually exist as a colorless liquids, or they can also exist as solids like the naphthalene balls which we use. They are solids and they have a characteristic aroma. Now, the naphthalene balls is used in toilets and also for the preservation of clothes because of its unique smell of the compound and its moth repellent property. So this is important about naphthalene balls. And these aromatic hydrocarbons, they are immiscible with water. They do not usually get solubilized with water, but they are miscible, or we can say soluble, in organic solvents. So we can say again that the like dissolves like. Now, when we are heating the benzene, we can say that we are getting a sooty flame with a soot deposit in the base. Now, let us look at the chemical properties. Now, usually the arenes are showing electrophilic substitution reaction, but under certain controlled conditions, we have addition as well as oxidation, even substitution reactions as well. So, let us discuss about the electrophilic substitution reactions first of all. Now, in electrophilic substitution reaction, we have to substitute an electrophile. Now, here the questions can ask regarding the reactions, and also they can ask questions related to the electrophile. And also they can give a set of reactions and ask which of the following is not following electrophilic substitution or which of the following is following electrophilic substitution. These are the possible types of questions which we can expect from this particular topic. So let's get started with the very first part, that is nitration. Now always remember, if we have benzene, we have 5 types of electrophilic substitution reactions: nitration, halogenation, sulfonation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. These are the 5 different types of electrophilic substitution reactions which are undergone by benzene. So let us start with the very first reaction, that is nitration. In nitration, what is happening? We are adding a nitro group to the benzene ring when benzene is heated with a mixture of concentrated nitric acid and concentrated sulfuric acid. And this mixture of concentrated nitric acid and concentrated sulfuric acid is known as a nitrating mixture. And one important point is that here the generation of electrophile is important in this particular reaction. This paragraph, which is given after the mechanism, is very important because this had a question in Neet previously. We have to remember that for the formation of nitronium ion, first step is what is happening is we are taking the sulfuric acid and we are going to react it with HNO3 also, right? So at that time what is happening is that this oxygen has lone pair of electrons and it is going to donate it to this particular hydrogen because this bond is slightly showing a tendency to move towards the oxygen atom over here. So what is happening is that there is formation of this structure, and also we have a formation of HSO4 minus. So here the nitric acid is going to act not as an acid, but it is going to act as a base. So this is important for the generation of electrophile. In the case of nitration, nitric acid in the nitrating mixture is going to act as a base. This has been asked in NEET previously, so this is important. Now let us see the nitration reaction. We have to treat benzene with concentrated HNO3 and concentrated H2SO4. So this is the base and this is the acid. As a result of treating these two, we will be getting the electrophile, and electrophile are positively charged species. So we can say that NO2 positive is the electrophile, and this NO2 positive is going to attach to the benzene and it is going to form nitrobenzene along with the elimination of a water molecule. Now let us see the second type of electrophilic substitution reaction, which is known as halogenation. What is halogenation? Arenes reacts with halogen in the presence of Lewis acid. Now what are the Lewis acid? We have anhydrous FeCl3, FeBr3, or even we have AlCl3. These are the Lewis acids, the anhydrous Lewis acids which we are taking for the process of halogenation. So when we are using these particular Lewis acid, what is happening is that we can get the corresponding electrophile, and the electrophile over here can be Cl plus or it can be F plus. So in general we will write it as X plus. This X plus, where X is a halogen, is known as halogenium, or we can say in the case of chlorine it is known as chlorinium ion, right? It is known as chlorinium ion because it is a positively charged species and it is not a negatively charged species. So we are getting chlorobenzene as the product when we are treating it with Cl2. Moving on to the sulfonation. Now when we talk about sulfonation, we are adding an SO3H group to the benzene ring. For that we will use the fuming sulfuric acid, or even we can use oleum to some extent. So if we are using this, that is fuming sulfuric acid, in the presence of benzene, then we will be getting benzene sulfonic acid, as you can see in the reaction. So here the electrophile that is formed is SO3H group. This is getting attached over here. Now let us see the Friedel-Crafts alkylation reaction. Alkylation means we have to add an alkyl group. And from where can we add an alkyl group? Alkyl group can be added into the benzene ring if we treat it with an alkyl halide, and if we have to do the acylation reaction, then we have to add an acyl group. For that we will use an acyl chloride as the reagent. This is important. For alkylation we will use alkyl chloride or any alkyl halide as a reagent, and in the case of Friedel-Crafts acylation reaction we will be using acyl chloride as a reagent. Now what is happening over here? Here the electrophile that is formed is CH3 plus, and that is going to get attached to the benzene, as a result of which we are getting the desired product. Now in Friedel-Crafts acylation, what is happening? We are getting COCH3 group, and this COCH3 group, COCH3 plus, that is going to get attached to the benzene molecule. As a result we will get the corresponding molecules like acetophenone. But there is another case over here. If we are using the excess of electrophilic reagent, it can lead to further substitution reactions, and if we are using Cl2 in excess in the presence of anhydrous AlCl3 and dark and cold conditions, then the chlorine will be substituting all the positions of hydrogen, and we will be getting a compound like this, which is known as hexachlorobenzene. So this is an important reaction. Now here is a question given here. Why do we get isopropyl benzene on treating benzene with 1-chloropropane instead of N-propyl benzene? So let us take the molecule 1-chloropropane, and another is isopropyl 1-chloropropane is treated with benzene. So let us take the reaction. 1-chloropropane means we have CH3, CH2, CH2Cl. So if I am removing the chlorine, I will get the carbocation as CH3, CH2, CH2. We are not going to do by mechanism, we are just going to do it in a general method. So we will be getting CH3, CH2, CH2 free radical, with a positive sign. That is, it is a primary carbocation. Now let us check whether there is any other possibility for getting stability. Yes, if I am removing one hydrogen from here and if I am keeping it over here, there is a possibility for a secondary carbocation, right? So we are going to carry out a process which is known as 1,2 hydride shift. And as a result of 1,2 hydride shift, now one of the hydrogen is going to shift from here, and this is going to get a CH3. The negative charge from this carbon is going to be removed, and we have the negative charge, which is positive charge, which is coming over here. So this is what we are getting as the final product, as the final carbocation. Now it is this particular carbocation that is reacting with a benzene. So we have benzene and we have CH3 and another CH3. This compound is known as isopropyl benzene, which is also known as cumene. which is also known as cumene, about which we will study in detail in the chapter of alcohols, phenols, and ethers, because from cumenes we can prepare phenol. Now, let us move on to the next topic, that is the mechanism of electrophilic substitution reaction. Now, for the entrance point of view, mechanism is not much important, but still we should have a general idea about this mechanism. According to experimental evidences, the SE, or we can say the substitution electrophilic reactions, they are following a three-step mechanism. Step number one is generation of an electrophile, and once the electrophile is generated, now there is a carbocation intermediate formation, and this carbocation intermediate is called as a sigma complex. This is important. And finally, this sigma complex is highly unstable, so it is non-aromatic as well. So if we have to make it stable, we have to convert it into an aromatic form. For that, we have to remove a proton, and that removal of proton will form the carbocation intermediate. And finally, the other part will come and join, and it will become a stable molecule. That is the process. So let us take an example. During chlorination, alkylation, and acylation of benzene, anhydrous AlCl3, being a Lewis acid, helps in the generation of Cl plus, R plus, RCO plus, that is known as acidium ions, by combining with the attacking reagent. So we have chloronium ion, we have alkonium ion, and we have acylium ion, which is formed as the electrophile when reacting with a Lewis base, which is known as AlCl3. So this is the process in which we can get these electrophiles. But in the case of nitration, as I have already told, we have H2SO4, which is acting as the acid, and HNO3 acting as the base, as a result of which we are getting NO2 positive in the second step of the reaction, right? So we are getting NO2 positive as the electrophile. Now we have the benzene ring, which is attacking the electrophile, which is attacking the benzene ring, right? So we have an sigma complex which is formed over there, that is basically the arenium ion, and this tries to get stabilized by the resonance structure. These are the resonance structures, but it loses the aromatic character because of the delocalization of the electrons, stops at the sp3 hybridized carbon, because to the position where the electrophile is substituting, that carbon is an sp3 carbon. And since it is an sp3 carbon, the aromatic character is stopped because the resonance or the delocalization of pi electrons happens only with sp2 carbons, right? So here we have an sp3, and as a result of which the process of delocalization will stop over there, and as a result of which it is going to be unstable. So to become stable, it have to regain the sp2 character. For that, it is going to remove this H plus, and that is known as deprotonation, right? It is known as deprotonation. So the sigma complex will releases a proton from the sp3 hybridized carbon on attack by AlCl4. So for the process of deprotonation, again we are going to use AlCl4 or HSO4 minus, that is the Lewis acid which we used before, and as a result of which we get some byproducts also, and we will get the major desired product. So this is the mechanism of electrophilic substitution reactions. Now let us see the second class of reactions, which is known as addition reactions. Now what is addition reactions? We are adding, right? We are adding some reagents, and here we have to study two addition reactions. One is of hydrogen and another is of chlorine. So when we add hydrogen to benzene, we will be getting cyclohexane, because all the double bonds will be broken, and to both sides we will get hydrogen added up. As a result, we will get cyclohexane, and we also have to study the catalyst which is used in the process, which is nickel. Now let us see the second reaction. The second reaction is we have to add chlorine molecule. So we will use UV light, and chlorine gets substituted at all the 6 positions, breaking all the double bonds, and we get benzene hexachloride, that is BHC, which is commonly known as gemaxine. So this is gamaxene molecule, benzene hexachloride molecule. Now let us see the combustion reactions. When heated in air, benzene burns with a sooty flame, as we have already discussed, and that will result in the formation of CO2 and H2O. So this is the combustion reaction. As in the case of general alkanes or alkenes, the same process is happening here also. We get CO2 and H2O in the complete combustion process. Next, we are going to discuss the directive influence of a functional group in monosubstituted benzene. So here we have to study about the ortho, para and meta substituents. So let us take one by one. The first one is ortho and para directing group, and what effect are they having on the benzene ring. Now we have an OH group here, right? Compounds like, or we can say functional groups like these, in addition to the halogens and OH group, they are an example for orthopara directing group. Now what do? They are activating the ring, right? But halogens are deactivating the ring slightly. However, they are also orthopara directing group because they exert more electron density in these two positions, that is in the ortho and para positions, right? So these are the groups, and the groups names are important, and we have to study whether it is ortho para directing, whether it is activating or whether it is deactivating. If it is bringing electrons to the ring, it is known as activating, and if it is taking away from the ring, it is slightly deactivating. Now let us take meta-directing group. We have NO2, CN, CHO, COR, COOH, COOR and SO3H group. These are known as deactivating groups, and they will exert less electron density on the ortho-para positions, and they will exert more electron density at the meta positions. Hence, the electrophile attacks on comparatively the electron-rich meta position. As a result, meta substitution will happen, and in the other case, ortho or para substituted products are obtained. We will study about this in detail when we discuss the coming chapters as well. Moving on to the last topic of this chapter, that is carcinogenicity and toxicity. Now, there are some compounds which are carcinogenic in nature, and they are aromatic as well. Now, what is carcinogenic? Carcinogenic means they have cancer creating, they are cancerous cells creating compounds, and they will have more than two benzene rings attached in the form of compounds like these. These are some of the examples of compounds. What do? They will cause us mutation, and they could also result in addition or substitution of genes in the DNA, and ultimately it will cause us cancer. So let us look at the examples one by one. The first one is 1,2-benzanthracene. Number 2 is 3-methyl-chloranthracene. Third one is 1,2-benzpyrene, 1,2,5,6-dibenzanthracene, and the last one is 9,10 dimethyl 1,2-benzanthracene. So these five names are important, and their structures are also important. They can ask in the exam. This one has 4 benzene rings. This one has 1, 2, 3, 4 benzene, and we have a cyclopentane ring. Here we have 5. Here also we have 1, 2, 3, 4, 5, and here we have 4 with 2 methyl groups. So this is all about the chapter, and now let us discuss some of the questions related to benzene. This is a question asked in NEET 2018. The compound C7H8 undergoes the following reactions. We have to say what is the product C. Now we can see C7H8 means we have to add a CH2 group, sorry, CH3, C6H5 plus CH3. That means it is a phenol molecule, right? It is, it is a toluene molecule. So we got a toluene molecule. So to this toluene molecule, we are going to react it with Cl2 and heat it. So if we are reacting it with Cl2 and heating, we won't get chloro substituted products. What is the reason? Because the reagent is absent. We do not have anhydrous AlCl3 written here. We do not have anhydrous AlCl3. We simply have Cl2. If we simply have Cl2, and if we are applying light or UV rays, then what is happening? It is going to substitute the hydrogens. the basic alkyl substitution happens, and as a result of which we get CCl3. Now this CCl3 is a meta-directing group, so the Br2 will be added at the meta positions, and now we have to react it with zinc and HCl, so this will add hydrogen to the compound, and we will be getting this final product as 1, that is meta-bromotoluene. Let us move on to the second question. The electrophile which attacks in the Friedel-Crafts acylation is acylium ion, that is this. Now let us see the sulfonation of benzene. The reagent used is, in sulfonation we are using SO3 as the electrophilic reagent. They have asked for reagent and not the electrophile. If they are asking what is the electrophile, then answer should be 1. Electrophile is 1, but since they have asked for electrophilic reagent, we can say this is the answer. Benzene undergoes substitution reaction more easily than addition. What is the reason? It is because of the delocalization of pi electrons. Next question, C6H6, which is benzene, is treated with a compound acid in the presence of AlCl3 to get toluene. So we have a benzene ring, and to this benzene ring we have to add a CH3. So for that we can use an alkylating mixture. An alkylating mixture consists of AlCl3 and CH3Cl. So CH3Cl can be used. Chloromethane is the answer. Now this is the last question. Toluene is reacting with K2Cr2O7 in the presence of H2SO4 to give us a compound Y. What is Y? This is a strong oxidizing agent, so it will convert the CH3 group into COOH, so we will be getting benzoic acid as the final product. So these are some of the important questions related to benzene, and with this we are completing the chapter hydrocarbons. So we will be having an assignment first. What is the assignment? You have to practice the MCQs from NCERT exemplar. From NCERT exemplar, and comment your scores. Like, you take it as a test and comment your scores. How much MCQs were you able to attempt correctly, how much you made mistake, and also mention the question numbers which you have doubts. In the end of the course we have a separate lecture for all the NCERT exemplar questions which you people are having doubts. So let us discuss all those questions. So for that, you do it as a test first of all, and analyze your performance, and whichever questions you have doubt in NCERT exemplar, please comment it in the comment section below. Now, before we conclude today's lecture, we have some important announcements. Basically, we have 3 important announcements. Number 1, today is 3/7/2020, and yesterday Dr. Ramesh Pokhriyal sir, the respected MHRD minister, has made the following tweet. Today, they are looking at the prevailing circumstances and requests received from the students and parents appearing for JEE and Neet examinations. A committee consisting of DG NTA and other experts have been advised to review the situation. They haven't yet discussed about postponement or cancelling the exam, but they are going to review the situation. That is what we are getting from the MHRD minister today. So we can hope for the best for today. So let's wait and watch, because we are going to get the report by today or maximum by tomorrow from the HRD ministry and also from NTA regarding if there is any change in NEET examination date or not. And second important announcement is, as per your request, we are going to start up the inorganic chemistry revision lecture series soon. But before that, don't forget to like, share and subscribe on the YouTube channel, and also support us in the Play Store by giving your valuable feedbacks in the Play Store. The link will be given below. So with this we are concluding the chapter, and next chapter we will be taking up the most easiest chapter of chemistry, which is environmental chemistry. We will be reading complete NCERT and we will be covering all the possible MCQs which can be asked from that chapter. This will be the first time in YouTube that we will be having a complete NCERT reading of this particular chapter. So let's do this in the next day. So till then, happy learning and keep revising.